Chevy Chase.
I'll just take a quick photo.
Please ask, take as many as you want. I'll get out the way. Alright, we haven't got a rush to do anything. We have oodles of time. Okay, and any time, just say, and that's fine. Okay, when you sit here, you get the impression you're in charge.
Yes.
But actually you're not. Alright? The man in charge, when anyone runs, is the person in the middle. I say man,
Yeah.
the woman or man, sorry,
Yeah.
Sue, I don't know if she makes a thing out of this, is the person in the middle. The medical officer who determines what's going to happen.
Yeah.
Alright? And it's not a case of get it started and you can whack it around with the joystick and have a bit of fun. Generally these runs lasted less than 30 seconds. Somewhere about 15 to 30 perhaps. Alright? Because all you want to do is whack someone up to 9G
Yeah.
and take them off again.
Yeah.
You don't sort of have them going around at 9G for 2 minutes.
No.
Alright? Or anything like that. Because of course in an aircraft that's what's going to happen. These controls are hugely complex. It would take hours for me to explain exactly what they all do. Alright, and I'll give you an example. Take the top right of those 4 black switches there.
Yeah.
Can you read what it says underneath and what the options are?
So disc strip lights.
Yep.
So you could have off both wings, left hand wing or right hand wing.
These are the desk strip lights. Alright, one over there. And that turns them on and off. Okay, and if you actually look at those switches, they are just light switches, apart from one,
Yeah.
which is the locks for the doors.
Push button illumination.
You might say they're slightly over-engineered
Yeah.
buttons for the job.
Yes.
Alright? So what I quite like is we have 3 G meters in here. We have the old analogue one, we have a rotating one, and we have the one, if you pull that towards you, but watch out for your... There you go.
Yes. I see what you mean.
We have the actual one that they probably use where they put a bit of paper with some sellotape on it and written down things. Now that would be used if they were doing a manual test on something like some equipment and they wanted to vary the speed. Alright, the G on that equipment. One of the things they did in here was the escape hatch for a Vulcan. You know Vulcans have 2 ejector seats up front, 3 crew facing rearwards and behind. Well, when they had to get out, the 2 at the front had ejector seats, but the 3 had to climb down, pick up a parachute and jump out, and they had to go in order. You couldn't all 3 go together because there was no space. It was 1, 2, 3
And
going
they had
down.
those weird swivels on the chairs. to
Yes,
try and get-
so you can
yeah.
get out and, well, get in and get out actually.
Yeah.
I've been in the back of a Vulcan, fortunately not to fly. It was horrible. Alright, I've been in the back of an F4. That wasn't much better, but a lot nicer than being in the back of a Vulcan. I couldn't see why anybody would do that for a job. Anyway, given that you're sitting there as a controller, if the run only runs 15 seconds, there isn't an awful lot for you to do. And what really controls how the run works is this box behind you. So if you like from this side, I'll come around the back because all the action you'll see from that side. Okay, I hope. No. Now I like to think of this a bit like a compact disc player, albeit a slightly early one, where this is the disc. And the way it works is you set how long you want your run to go for on the timer, and then it starts idling round, and when you press go, this starts rotating. So it rotates in this direction. So this wasn't working last time, and it's still not working. It's like a cam. This is a follower, and here you've got a whopping great long arm. This is the pivot. So this end moves according to the follower, and that just controls how fast it goes. And the further it goes across, the faster it goes. Now this is, I found out on my last tour in fact, is exactly how lifts work. When you select a lift, you want it to accelerate away or slow down when it gets to the floor, you have to have one of these discs. And all that happens is to speed up, it spins round like that, so the follower will get to about here, and to slow down it goes backwards again and back to its starting position. So if you want to do different tests, you have to take your disc out, go to your CD collection, which we keep in a cupboard here. Shall we do a 11? Oh, that looks good, doesn't it? Okay. Bum, bum. Get the lugs in the right position. Slip it back. What you can notice is, alright, that it's a lot thinner. See how off centre that is? Yeah. The 11G is a lot thinner, so this is going to travel further across, so it's going to go faster. Going to have a little blip there, but and that's how it works. That's exactly how it works. It's all set up on here. All this guy's got to do is make sure it does what it says, and if it doesn't, press the red button, which of course the guy in the middle has as well, to do the emergency stop. Yep. And talking of emergency stops, this is quite a nice touch. You see this rather, what we call it, after production edition of a metal bracket, I saw something. This is the overspeed setting. Okay, and you can see that it's currently set on 32 RPM. That's 10G. So if we're testing to 9G, once it goes past 9G, we know we want the overspeed to work. But there's also an overspeed setting for 55 RPM. That's 30G. And we don't think that's ever been tested or used since commission. And clearly they didn't want someone to accidentally move the switch. Did Sue tell you which way the round this goes? When it's operating, it only goes clockwise. Right, but here you can see we've got a couple of lights, let's say clockwise and anti-clockwise, okay, that you can select, and that's because if you want to inch it round, have the gondolas in a specific position for maintenance or whatever, then you could use this. But for runs, it only ever went round in a clockwise direction. These lights are all the different checks for the system. They would go off if things are ready to go. So if the light's on, you know you can't run and there's something wrong with it. And really, that's the sort of how it works. We've got more to tell you about, but do you have any questions on what I've said so far? Has it all made a little bit of sense? Yeah? You'll see a video of this moving when you go back down before the end. You can sort of see how it works. I would really like put power back on the cabinets and the desks so we can at least have it lit up a bit. But of course that's not my decision and I'm not paying the electricity bill. Right, we will get a chat about it. Oh, I should have said, this cupboard is full of these things. There's 2 more of these in one of the labs opposite. So there's every profile, right? Sue says going up in 0.2s, but you can see there are the occasional ones that aren't in 0.2s, but 0.2 of a G is usually a good enough tolerance for doing the work. One of the most important things about a centrifuge isn't what G it goes up to, it's how fast it gets there. And this accelerates at 1G per second. So if you're sitting still before the beginning of the run, you're already at 1G. So it takes 8 seconds to get to 9G. Put on the extra 8, yeah, and then 8 seconds to come back again. And when I was researching this, I was quite interested to find that we used to call the rate of change of acceleration jolt. The Americans called it jerk, all right? And now most people who use the term, which isn't very often, use jerk. And then the bit that amused me was the rate of change of jerk is snap. All right. Can you guess the next 2 in the series? What comes after snap?
Crackle and pop.
Correct. All right, it is. That's one of the great science jokes, and that nobody's ever going to hear it. Well, no, who is ever going to sort of ask what comes after acceleration and get all the way up there? This is quite a good diagram just to get a little bit of an overview of things you might not have spotted You know, first of all, you certainly won't have spotted that if that's the height of the chamber and that's the height of the motor, all right, then we've got a very big 2-storey underground thing, and the doors opposite us were probably only ever used for getting that motor in here, because nothing else requires doors of that height within the assembly of the centrifuge. And you can see that that's further encased in 2 stories of steel reinforced concrete. And the slightly worrying thing, which you may not appreciate, is when you look at this, it looks like you've got an axle going all the way through. But in fact, there is nothing between the seats. These things that are drawn here in the plan are actually forward of the centre axis. Everything is mounted on the flywheel. So there's nothing here. This is just a tube that goes up for the gas and mostly electrical slip rings up into the top. Everything is mounted on this. So if this wobbles, all right, which it did when they first tested it, so it had to be reinforced with further steel to make it work. And you can see the sort of scale and the complexity of the building, and the engineering that went into it. You'll also find out downstairs there's a crane in the space above the roof, and that was only used in the construction. It's sat there redundant ever since.
And that engine hasn't run since 2019, I guess.
That's correct,
Yeah.
yes, since the end of March 2019, which is actually comparatively recent.
Yeah.
The big advantage of the Cranwell one is that you can fly the cockpit. All right, so this one you only get G going down through your pants, but whilst going round you can then fly the cockpit as well, so it's much more realistic. And the other big improvement is this is a bit like the sort of turret you get at the back of a Lancaster, the gondolas, on a much bigger scale, but it sort of moves in a similar sort of way and it's built in the same sort of structure. And if you wanted to have a cockpit in there, you'd have to do a lot of redesign. But with the new digital cockpits, you can just pull one cockpit out, because it's all screens and electronics, put another cockpit in very, very easily. So I think they have 3 different cockpits that they can swap over. I haven't been to see the one at Cranwell yet. I haven't been invited.
So presumably they can have side G as well.
Yes, yeah, they can, which makes a big difference, you know.
Yeah.
I mean, this is really good for when it was built, because we just didn't know the effects of G, and we didn't know how to counteract them. So things like the pressurised trousers, pressurised breathing, this was a superb facility for developing that. They also use this to try and cure air sickness on aircrew. Did Sue mention that at all in the talk? Well, it seems really cruel that if you have aircrew suffering from air sickness, that they have to come here and be flung around in this. But as I was saying earlier, when you fly in the back seat of a fast jet as a navigator, you've got helmet, oxygen mask, pressurised breathing, which means you have to get the air out of you. You've got these things going off on your legs every time you put a G. On the F4, you've got a screen between your legs which you have to keep your head down to look at to find the targets, and you have no idea how the aircraft is going to move, a bit like being a passenger in a car being driven, and that doesn't really make for a very good environment. Plus the sides of the canopy for the navigator are up here, so the only view you can really get is of the sky by looking up like that. It's not a very pleasant working environment, and I fully sympathise with anybody who suffers from air sickness from being in it.
The RAF must have less pilots now than when this was really, really going.
Oh gosh, yes.
Yeah.
Yeah.
But I guess other people get put in it. Or?
I joined the Air Force in '73, and there were 88,000 RAF personnel then. It's now in the 30,000s. There are more people in the Air Training Corps than there are in the Royal Air Force, and I think even the Army's down at 80,000 now. So which is tiny. Yeah. In the sort of global size, what global size has been. Did you come in via the Holiday Inn roundabout, or did you come from the Costco's? Holiday Inn, the last set of traffic lights you came to, there's a little brick building substation, and that provides the high voltage supply to here, and it comes on the floor, and in here is the box. And I'd like to say it's disconnected, alright? They didn't tell me for about a year it isn't disconnected, because they can't go into the substation there, because all the gas has come out from the gas field circuit breakers. So, and there's a dispute about whose responsibility to fix it and all that sort of stuff. But it is quite sweet, the cables coming underground there, because we have this tiny open on the floor. And if this, you will see, it floods for the high tension needs. Yes, alright, you get them nicely to the panel, and below it, why I wasn't looking is this pump isn't actually working. Could be a fuse here, so but anyway, electricity comes in through that, and then it's connected up to the wall in the circuit breakers, so that goes into there, oh, are you? Okay. Tell me more, I don't know about them.
Well, these are mainly used for, you've got two different applications, so you can have which you can supply or you can have internal.
Right,
So, normally, it goes in, you wrap it up,
yeah.
and it makes contact.
Is that the wrapping up handle?
No, yes, it is. So,
There's a little stick there, and you have electrical and power. Alright,
so that slots in,
yeah,
you push it in,
yeah,
and then you wrap it up into position,
yeah,
and there are covers under there,
yeah,
but the electrical box
Yeah.
under there,
yeah,
comes in there, comes in the back of it,
yeah,
and then you wrap it up, you make contact,
yeah,
sometimes a little fizz,
yeah.
and then supplies on to.
Brilliant.
Brilliant.
Yeah,
What you can also do is for the usual little marks on the floor
yeah,
somewhere, and you can wrap it in slightly further, looks like the mesh bar,
yeah.
and that allows you to put an earth on the cabling.
Right. Because originally, I believe, the sort of switch to turn everything on was here.
Yeah.
And only later on they thought there might be an idea of having a more remote switch, rather than having everybody staying next to 6,600 volts to switch it, you know. Just a few minutes.
We used to have, especially with a kit,
Yeah.
which was a string with a hook on it.
Yeah.
And you'd go outside the door,
Yeah.
just trip it on.
Everybody's getting out there.
But certainly we had an operations room, and we had a blast-proof wall
Yeah.
between us and these.
Yeah, well, honestly, the guys used to put it on here, and then they have to come over here because this, winding this down, would increase the current. This is a water-filled potentiometer, really. That will increase the current, which will be coming round, all right, towards the motor, of the motor generator. But first we have this little capacitor. Because the motor is a whopping great conductor, you get current ride, so this therefore gets it back in phase again. And so they wind that all the way down until, and let me get to that, we're already in the running position. Excuse me briefly. Now this will be in the starter position like that. When it's up to speed, they will wrap this round, indicator comes up, and then it's just running at full speed, and they would leave it. And even if they were only doing 1 or 2 runs in a day, they used to come in here, get it started, and clear off, because it was a bit noisy in here. And so we have a motor there, generator for a DC for the core, and a little generator here for the field. Alright. And where is the warmest place in the building? It's here. If you put your hand in there, you'll feel a balmy 19 degrees.
Oh yeah, lovely.
And same under the floor, that's the passage where it goes to the motor. It's still being kept at 19 this, are you? Which I have very strong reservations about, because it's just not environmentally sound. There must be other, if you want to stop it from deteriorating, there must be other preventative measures you can take. You pick one up, yes, pick one up, pose with it, you know, anything at all.
At one stage, I worked at Centrifuge,
Yeah,
and we had a similar setup,
yeah,
where you had a control that you'd use to run up and down the motors.
yeah,
But we also had big battery rectifiers to DC.
yeah, yeah.
And these were the big tank for the mercury. And every day when the top went to go on the top of the mercury,
Yeah.
nobody ever wondered where it's going to go.
And they're also all right.
I suspect it's in Farnborough. That's how around it.
So this sort of engineering, I said about the lift technology upstairs, this was commonly used in places like steel rolling mills, and also for mine shaft lifts and things like that. There's one down in Cornwall, which I've been trying to get them to tell me how they're keeping it. It's not in use, but maintained so it doesn't deteriorate. I've had any luck so far. And then this is just, if you're a mechanical engineer like I was, this is what electrical systems should look like. Alright? Because you can actually see what's going on. You can see things switching. Alright? Some of them have manual handles on anyway. The Thyrotrons are early thermistors. Thermistors about that size now in electric circuit. When the building was built, they thought, oh, we'd better provide 3 spare valves. 3 spare valves are still in their cases, which are straw and wood style cases, alright, upstairs in a cupboard. And this, I apologise for the buzz, but it does give a good feel in here. That's for the fire brigade's switch, isolation switch, so they can just turn everything off. But I think most impressive of all is the domestic power panel. I open this, I'm still secure with it. The lock really works. I used to have houses with fuses like that.
Yeah.
I think if I pull that one on, it'll go dark in here. And you can see the sound booth if they did want to communicate in here. But the guys who started this up would usually then go straight up to the control room and sit with the controller while the one was going and make coffee, I assume. And this was just the maintenance. And it does actually move and work after a fashion. So that's not one of the redundant bits, that was actually used for lifting the casings and doing work on the motor generator set. Right, we're nearly at time. Are you happy? Any questions? Do you want to take some pictures while we move on?
I'll take a picture of my diagram if I have.
Oh yes, you can have hours of fun. Why don't you sneak back in here when Sue's talking and enjoy it?
Yeah, I've got to build one at home.
You get to see the inside of one of the boxes. But if I turned it upside down, you'd see that all the capacitors have been replaced with modern ones.
Yes.
All right, you just can't do it like this.
But everything, lovely set of valves.
Beautiful stuff. Upstairs, the sound systems, we've got 2 sound systems which are duplicated. Right, so there are 4 valve power amplifiers in the cabinets upstairs, which are for me, if they should ever decide they're going to knock this place down. Alright, they've got my name, as have the light fittings in the hallway.
Yes.
But, you know, but they're 4 beautiful, absolutely beautiful. And it's only for the intercom. I mean, it's just tragic.
Yeah, I know.
Right, we better go back, otherwise I get called on in a minute. I'm being told off. Okay, fine. We'll go back to our solid answer. Yeah.
Yeah, the only thing is if you have a reason you have to have yours cleaned again.
Yeah.
Because every time they actually operate, you draw the stock, which carbonises some of the oil.
Yeah. Okay.
And a gantry will use that and switch the capacity out to 1 kV. So both brokers can do it out every time you go to the bridge line. So
There's a lot of work training for it.
yeah.
Well, the service manual for the building is actually made massive work. It doesn't do the equipment. There is battery backups for things, so the power did go down and everything was running work. You still have a whole set of batteries upstairs, not one of that. It may be zero, I assume, with time at some point, and I assume at some point water films, because it's still water films, it's going to leak or something will happen with it if you don't use it. Freeze! Freeze, yes. No, they're in wooden boxes, so I can't really see what the thing is, but they're still walking back and back to them to the voltage. Yeah. It's a hugely compact building. Something I've shown you, there are 3 of them in the building, one of them now again, so we have to go down. We would really love taking on that. Officially, with the phone, there was a concern to put a bit of a jacket and it's slightly dangerous in that you have to run quite a short one to get to the lowest. Slightly dangerous? And it is a shame because when the using it very much longer, they didn't get the same level of maintenance control into the building. And then it's empty, and that's never good in a building like this. And particularly if it's in the damp, as I said, it's less than not. Absolutely fine. It's a work nice 150 flat roof. Vast area, and you know what, we've got little garden room in some of the places up there, including trees. Including trees, so, and it's all very well, we try and do some maintenance control. We're all on, we're all retired. Not you. You're not old, alright?
Just retired.
Yes, retired, yes. But, yeah, look, it's quite difficult for us to climb ladders and working at heights of on top of that or on the roof. Height is not agile as it used to be. Please do. Yeah, come on.
So you can see, so the chamber itself,
I've done a couple of trips. It's the most interesting one.
just to give you an idea of size, this is 80 feet in diameter. The arm itself is 2.5 feet long. It's got
Difficult,
width
isn't
of
it?
The foundations, and you'll see the photographs later, construction, they're 27 foot deep steel reinforced concrete, because obviously that is the motor, it's got to, take away from that of the motor. These walls, so you've got 2 foot thick steel reinforced concrete, so it'd be funny, if the developer had tried to knock it down. And then the doors, you've got, so there's 3 sets of doors, got half-inch plate steel filled with gravel. So any idea why you've got that with the doors?
In case this breaks and something.
Absolutely. So this is, so at 9G, this is going around at 30 RPM. The gondolas are doing 63 miles an hour. And actually it can go up to, it was designed to go up to 30 RPM, so that 30G, so that would be 54 RPM, and I think that's about 115. So this is a 40-ton rotating mass. So I think it's pretty impressive that it basically will go from 1 to 9G in 8 seconds. So it'll go from 0 to 63 in 8 seconds. I mean, that is, yeah, that's pretty impressive for that size and that weight. So,
I never worked that one out.
yeah. So I won't talk while they're talking. It was just 2. Yeah. Right, so above us there's a ceiling void. Heating and ventilation upstairs. In there you've got the heating and ventilation system, which obviously is turned off at the moment because it costs a fortune and it's
Take you through.
Thank you. You've also got 14 light boxes. Now, originally they had just 2 500-watt bulbs in, but in the 70s they were upgraded. So they've now, each of them's got 7 fluorescent tubes, and you can have any combination of those. So this is 4 tubes on. And every couple of years, some poor sod like Andy would have to go around and change all the tubes. That's 98 tubes. And try and do that without falling through the ceiling. As you can see, that wasn't Andy, that was an electrician. Last year we had a problem with the lights and he went up there and despite being warned about it, he stuck his foot through and it hasn't been repaired as such. And then you can see down the centre there's a piece of removable ceiling. So this is what's up there. Sorry we can't take you up there at the moment. But it's a massive head hazard, also asbestos. So this is the heating ventilation system. This is asbestos cement. It's all enclosed, so it's safe, but obviously you need to be careful. And these, you can't see in this picture, but some of these run right across the walkway, and even I have to really crawl underneath. So it's a big hazard. Here are the original light boxes with the 2 500-watt, and then here are the new ones, or the replaced ones here. Now this is what's underneath or above that removable ceiling. There's the 2 tracks here, girders, and on those are these absolutely gorgeous 25-ton cranes. They're obviously still up there and they will remain up there. They were used once and once only, and that was to drop the motor into the pit. And it says here, crane withdrawn from service August 1954, consult insurers before use. So they've only been used once, although to be fair, one of them does have a 2-ton electric hoist on it, which is used to take the gondolas on and off. But please note, these were all hand operated, chain driven. So men were men in those days, you know. They did it all themselves. But yeah, it's absolutely brilliant, absolutely gorgeous. Now what we'd like to do, if you actually go in there, you can sort of go up the steps, just hardly in there, and turn, you can see one of these. So we thought it would be really nice to put some sort of glass panels around so that people could, you know, be perfectly safe, but they could go and actually have a look at these things, because again, the size of them, beautiful. Can't remember now.
It's the track is, if you look up here, right, you see you go to the centre and you go out what, 2 to 3, the 2 big square panels, the widest ones to start with. That's how wide the track is roughly. Okay.
So the crane sits on that, and you can see here.
Yeah. If you stand on the walkway, the top of the crane will come to about here. So you know, that's rough. That's a rough dimension. And then lengthwise, you can see the length gives you an idea.
Yeah. But they're beautiful.
But when I was here, the inspector used to come once a year to make sure and check them that they're still there and not being used, and do an insurance check on it. Yeah. All including those cranes in there. Sure. They used to use those quite a bit on that something. Okay. Right. My job, I was brought in by ML Aviation to work on this site with the RAF. As Sue said, a long time. My job is to help with all the maintenance of the rig building and work with the doctors on here. So one of the jobs was to look after this part, the motor generator, the motor in the bottom of the pit. It's mounted on, as you say, 27-foot concrete underneath. So in the mornings we would come in and do our daily checks, and that was to make sure all the brake systems work, pressurise them up, and test them, because they're working at 3,000 psi. And there's 8 brakes, 2 systems of 4, and down below there, which are underneath the checker plate, which you can't see at the moment. And then other bits and pieces we would do. Saying there's all the brush gear in here, so if I stood there I can just about see into them. If Sue went there, she would just about get to here, you know, so we'd have to stand her on the box on that side. But down through the bottom we have all the underneath another floor. This is all live, and at those early days in the 70s there was no health or safety as such, so this was all open, and it still is, but there is a bit of protection now. And then you've got all these overspeed devices. You've got the gearbox here, you've got the tacho generators, and then you've got overspeed devices, which are safety systems on those, on that side of things. The idea is, when you noticed on the video there was a bit of flickering between 9G and 9.1, 8 and 8.9. Well, that's these tacho generators trying to keep the gondola, the machine, at constant speed at all times on that. Now, this here is one of the overspeed devices. It doesn't look much, but it is a lifesaver on that side. And one of the jobs we used to do on a regular basis, and every 3 months, was for me to go down, nice big screwdriver, and we'd run the motor generator set. I'd sit down there, they'd buzz down, say, right, we're doing 10G, so the single one was a 10G machine going, and just jam the screwdriver into there and trip it, and it'll bring the machine down within 9 seconds. Then you do the 15G and the 30G. Okay, so the 15 used to be 20, they dropped that down a bit, and then you did the 30. So the machine was going round above my head quite happy, and you just trip them out with a screwdriver on a regular basis to make sure that they work. And we do know they work on that side of things. Right, in here is a 1 megawatt motor. It's an old steel mill roller motor, so it'd be 1940s or probably very early 1950 machine on that side. This is the cranes that Sue was on about. You can see through that piece coming out the top all the way along, and then we drop down through this part here, because this is the bottom of the cover casing, and this is the top. And this is a 10-inch ball bearing down here, and here, roughly about here, is a 17.5-inch split roller bearing, which occasionally would come out and very rarely be touched in case it made noise, and that just for maintenance wise. Got some stabilisers around the outside, which help stabilise the flywheel and the actual arm, just to keep it there. And then in the gaps here, which are not filled in, is the brake system with the pads. Now the brake cylinders were about this diameter, okay, and the pistons were inside, and they'd only move 40 thou on them. And that's they're a clamp. They're not a braking brake as such, because all the braking was done on the MG set, which is a regenerative braking system. And these were a holding brake on that. From there onwards, then, so go from here. Now what was happening in the early days, they noticed that the actual motor, even though it's all on that concrete and RSJ underneath, was actually doing this, trying to rip itself out of the ground. So they put these RSJs in across in 2 directions, that way and that way, just to stabilise it on that, which made maintenance quite a bit awkward when you used to sit on top of them and having to put your feet inside and play around and do whatever you needed to do. That was, say, few and far between on that side of things. So that's just a simple solution. Here, you've got the boxes which used to go on the end there, but that was for doing, I put them on once, and that was, instead of doing G this way, we were doing it this way. But Sue's got more information than that than I have. So that was really the main part. That's just a simple bit, because we used to build all the rigs for the doctors and help them out. And then when it was running, I used to sit outside the door, ready to put the jacks in, and if it was necessarily needed, and make sure it was all locked up and help strap the pilots in and dressed them.
Brilliant.
Did everything. We did everything. Okay? Yes.
Yeah, if we just like, so if you want to take, yeah, and then you want to pop over. So that's obviously related to the octagonal and everything. So underneath there as well, and what we would, one of the things we'd like to do is we put some of these panels and put glass or perspex so you can actually see it.
That'd be nice.
Yeah, I mean, you never. It's really difficult photographs to get an idea of the size and scale. So these are the observer stations, and this is where, when you had a person, so you did a run with a person, you'd always have a medical officer sitting in the middle here, and they would be in charge of the run. So would you like to come and sit up? So, fold you.
Yeah, having the monitors there.
Yeah, so obviously the consoles, the seats, and all of this are all the original 1950s.
Yeah.
Clearly the flat screens are modern. In the original, very, very early days, I'm told that there weren't any monitors at all.
Yeah.
And so the medical officer would just see the top of the subject's head, because obviously the gondola swings in, which is why that's. So he would see himself on G-Lot, because he would see the slump, but apart from that, in my day, we had the old cathode ray tubes, the BDUs, and then obviously Kinetic replaced them with the flat screens at some stage. So the medical officer was in charge of the trial, and he or she would decide what happened next or whether to terminate. So they were responsible for the health and welfare of the subject. So they would be continually monitoring the subject. On one of the screens, they would have I always call it the in-cockpit, in-gondola video, the head and shoulders. On the other screen, they would have the physiological data. So we were always wired into an ECG. I say we were always wired into an ECG. My husband had a particularly hairy chest, and he didn't like having all these electrodes. I think that's when they pulled off. And they also didn't get very good connection. So they tried to then, shade little circles on his chest, and it was went, So because he was so experienced, but the rest of us had to do that. And any other physiological data, depending on whatever it was that we were doing in terms of the trial. And also trials data would come up there if they wanted. So on the left you've got the communication system. So the medical officer was the only person that was in communication with everybody. So he would be talking to the subject continually. He'd be talking to the control room, saying what run to do next or what to do. He'd be talking to the record room to make sure that they were ready. And then they would head off on the run. Yes. Now, well spotted. Now, I'd never sat here, and I wouldn't want to, because you're obviously rotating. You're not subject to any G because you're so close to the centre of rotation, but you're spinning round. So at 9G, it's 30 RPM. Now, I'm told that as long as you kept your head still, you would be okay. The moment you move your head against that rotation, you're going to start to get all sorts of disorientation. So it's due to the semicircular canals in the ears, the balance mechanisms. If you keep your head still, said it's fine. Andy sat in the middle and said that was okay, and my husband did as well. But I wasn't going to do that. But the sick bag is just in case someone were to move or do anything. Now the trick is that if you're going to be sick, please get it in the bag, because you can imagine what. And apparently, if you were sick and you didn't get it all in the bag, it was your responsibility to clean it up afterwards.
I remember that from the back of Chipmunks.
And then you can see you've got sick bags in the door of the gondolas. So you would also get a strange sensation, nothing to do with this, for the subject. So it was absolutely fine as the gondola sped up and the G came on, that was fine. But when the gondola decelerated, or when the centrifuge decelerated, and the gondola swung back up again, you get something called the Coriolis Effect. And it's just a combination of the deceleration and the rotation. Throws the semicircular canals again, and you get this tumbling sensation. So you feel, and it's an artifact of a centrifuge, of this centrifuge, and you just feel that you're tumbling. So your ears are telling you you're doing this, but your eyes are telling you you're not. And it's, as you know, it's that difference between what the ears are telling you and what the eyes are telling you that actually makes people ill. Hence the sick bags. I was really, really lucky because I hardly got that tumbling sensation at all. And after about 3 or 4 consecutive runs, nothing. I was completely desensitised to it. Other people got it really, really badly. And I do have a video of someone actually physically being sick, which I showed to the kids, but I spared you that one today. But I don't know whether you watched YouTube, Jeremy Clarkson?
I don't remember seeing that one.
Okay, it's worth a laugh. If you look at it, a search on YouTube. It actually stars Andy as well. Yeah, Jeremy came, it was after my time, on the Centrifuge, and I think he did one 4G run, and he obviously got the Coriolis Effect really, really badly, because he just completely wimped out, and he said, no, so I'm not doing anymore. I love it, yeah, what a wimp, you know. But yeah, he obviously got it really badly, and you don't know beforehand how you're going to be affected. And unfortunately, there's not a lot you can do.
No, it's the same with the sailing. You get surprising things. We taught some poor lady, middle-aged lady, and she was really, really keen on sailing. And we took her on a sailing course, and she got about 4 or 5 yards off the beach and was immediately ill.
Really?
And and she was into it, and she never been ill before, and it was just the motion.
Yeah, and there's nothing you can do about it.
And of course, Nelson was always sick.
Yeah.
One of those weird things. As you say, different designs.
Yeah. Some things you can desensitise. I said that, I think if people persevered, they'd be better at it, but they would still not be well. I was just really, really lucky that it didn't bother me in the slightest. I guess you both know about slip rings, don't you?
Yes.
Yes, lovely. So we've got 3 sets of slip rings. We've got the original bronze slip rings, which are underneath the motor, and they supply power and the running of the communication system or the teletalk system. You saw the cabinets upstairs. So they come up the motor and they feed underneath the walkways, and they go on the right hand side is the power, into the gondola, and then on the left hand side is the teletalk system. They are original 1950s. Then we've got the data slip rings. They were replaced in the 1970s, and they sit up in the centre. There's a little room in the ceiling void, and they supply the data from the gondolas and from the centre stations. So as you'll see, when you see in the gondolas, there's various patch panels, which you connect in the various recording equipment to. They then run along the top here into these spaghetti junction boxes here, up the centre, into the silver-plated slip rings in the middle, and then they go out to the various, the control room and the recording room.
So now it would all be wireless, wouldn't it?
Oh yeah, nowadays it would be, yeah. And then the final set of slip rings, you've got the gas and vacuum slip rings.
Oh, right, okay.
Yeah. And as they supply the gas, breathing gas to inflate the trousers and things like that to the gondola. So they're actually right at the top of the building. Comes down the centre, and you can see all the switchery here. So that will then connect the various lines to the various gondolas, and again you can see the pipes travel along here, and they go into the back of the gondola. In the early days, the gas was supplied from gas bottles in the gondolas, but obviously once you start doing the pressure breathing, things like that, you need to actually have a proper controlled supply of breathing gas. Before the 1970s, there was a set of slip rings which, again, did the data things at the top, but they were mercury. Well, there was some normal slip rings, and there was 30 mercury troughs.
Yeah. Yeah.
So again, they were replaced in the
Again,
1970s.
I dealt with those, well, not mercury on rectifiers and things at Daventry, so, yeah.
Yeah.
I was saying we had the joy of every day we topped up the mercury. Nobody ever thought, oh no, the mercury's gone.
Yeah. No, not good.
Glad to get rid of those.
And then this big red stop button here was actually put in after my time. After it only had, as far as I'm aware, the Centrifuge only ever had one failure in its 64-year life, and that was in 1998. And this was put in afterwards. And I've got a film of that at the end, and I'll talk you through it then. Right, I think we're about to skip over.
Okay.
So I always.
Okay?
Right.
Right. The gondolas. Right. Those there.
Yeah.
Right. We had to remove them to do changes on everything. Take things out, put things in. They all had to be balanced and weighed and what have you. So these would be wheeled out, green to the green and the red to the red. And then you disconnect everything. Hook up, you get them there, jack them up,
Yeah.
and then you pull off the gondolas. Because you'll see the rams on the sides on that.
Yeah.
Okay? And that's why we've got a nice big weighbridge there.
Yeah.
Then you strip them down, and what you do, this one is probably it's being weighed, it's in an all up weighed position. So you do a weighing and a leading and trailing, whatever. Now you do it, we're working on the green car, so you build it all up, you put all your weights in, and then you bring it in here, you do a lead, trail, an all up weight, and then you get your central gravity right. The test run.
Right.
And then you do it for subject run.
Okay.
And then you bring your red car up to your green car, because that acts as a counterbalance to that one. So you can imagine what's going to happen next. You want to use both cars, so you have to swap them over. So you have to do the same with the red car, but then the green car then becomes the counterbalance, so it's all written down for whatever trials that you're doing. So in the morning we're doing the subject, in the afternoon we could be doing equipment. Because
Okay.
it's all weighed, everything is weighed and measured.
So one of these is for equipment and the other's for.
Sorry?
So one of these is for.
Well, that one is mainly for pilots.
Right. Okay.
This one is for dual, pilot and equipment.
Okay.
But you can do some equipment on that. But that one's geared mainly for typhoon,
Okay.
on that sort of side of things. But that was what would go on. So you move all your weights around on that side of things. And that's what that big crane, that's what that patch is there, that's where the crane comes down through. That little hole,
Yeah.
that one there, that's where the crane will come down. It's sooner on the back, a 2-ton crane.
Yeah.
In that one, which you can see here.
So you'd have additional weights that you could put into.
No, what would happen is you'd move all your weights around. The only weights that you basically moved from one to the other was the weight of the subjects.
Yeah.
Because it being an international place, we were getting people from all over the world, pilots, doctors, what have you,
Yeah.
not knowing who were coming. And so when I look at the three of us, we're all different weights, sizes
Yeah.
and everything else, so you had to work on £190 as an average weight for a subject.
Yeah.
Okay? And that's what you do. And so that's why you move. So what you would do, once you say we're using the green car, that one would be balanced, but you take £85 off that seat
Yeah.
after the test run, put it on that £85, so that makes it £190, which is the subject.
Yeah.
All right, and again, you swap it over in the afternoon, so you swap everything around, move the bags up and down and around the gondola for whatever we're doing.
Okay. So when you knew Clarkson was coming, you needed to move a lot of weight.
No, we still worked on £190 because we don't know his height, and his height was his problem.
Right.
Yeah.
Yeah.
Okay.
Yeah. He is quite a tall guy, isn't he?
He's a big guy.
Yeah.
He's a big guy.
Because I remember he bought a GT40 and he couldn't fit into it.
Oh, Jack Brabham had that problem.
Did he?
Yes, if you noticed the Brabham bulge in the
Yeah.
GT40, that because of his helmet, because that's why you could get into the GT40.
Oh, I didn't
That's
know
come
that.
the Brabham bulge.
Yeah.
Right, paintwork on here. This is for crack detection.
Yeah.
All right. So we'd strip the cars off, take them down, take all the floors off, planks across the top to walk across, and then with electric field around and magnetic field, magnetic crack detection on there. Put a charge through, spray a dye in, and then put an ultraviolet light on it, and that would show up any defects, like they were having on the high-speed trains of recent times with casings. Now this has got a few over the years, because she's 64 years old. So there's one in here, which you see is being done. There's another one here, and it was done every couple of years on those types. Now the gondolas weigh 2 tons apiece, and they're held on 12 bolts this end and 12 bolts that end. Now the bolts would be removed, put in their green box, the red box, they would be sent away, the spares would come out, and they would be put back in, because these are all torqued up to 42 foot-pounds a piece. So that's a lot of torque to hold them in place. So anything that was found damaged, say it's destroyed, and a new one was made, and they would go back into store when they came back from crack detection. Right?
Yeah.
Okay, so that's it. I'll go up. Right. As you'll notice in here, you've got different bags, coloured bags. You've got an orange one, which is for £5, green one is £10, and the white one's on the floor for £20 bags. These are the ballast bags that we would use for putting on the seats, and also for moving around for whichever gondola we were using for test runs or for subject runs, equipment runs. So you just move it up and down and backwards and forwards across, so you keep the machine balanced. So I say it's balanced to within quarter of an inch of the centre line, to within about £5 of each other. If we couldn't quite get it quite right, we can add ballast at the top or some extra ballast at the bottom and get it exactly right. Now then, you've got a damper at the front, friction brake at the back. They were to keep the gondolas, stop them doing this. Because you've seen what happens at the fairgrounds, the big wheel, when they stop, the gondolas swing. You don't want that on this. So it goes out, and it just goes out and stays in a set position, and then comes right back up. So we can get the door open easily, and but on that fork, on that side of things. You've got your Faraday cage, when you shut the whole of the building up, and in here stop any interference from the outside, on that kind of thing. Cabling is all recording cables, breathing cables, and this is all the tubes which were put in over a period of time by me and a couple of others over a period of time from outside. The breathing bottles we had were of £180 a piece. I took 180, they took 180 psi pressure inside them, and then they wouldn't last long. 2 runs if you were lucky, then you have to change it. So your pilot will stay and you clamp them behind them and take them over. So that's why we've got a complete system now. It goes from the outside all the way through the building, right the way to the top, back down the tube, and into the centre, so you can divert it to green or red gondola, like you can with all the cables. And that's what went on with that. So we never run out of gas supplies.
I like the drill table, so you could fit different experiments.
Yeah, that's the idea of it. Yeah, so you can put all sorts of different things on it. It makes life a lot easier. Okay. Right, mind your head and back going through here. Okay. So you put your feet on the footrest. This is the mixed one, which you've got pilot or subject, both the subject and equipment on here. So if you have wearing equipment, you'd have be plugged in on here for your ECGs, measuring body temperatures or whatever else they wanted to do to you on that. You could have a machine behind you for hot and cold trials, because you've got a suit and all your flying clothes just to see how you're getting on. And then you'd have electrodes stuck all over your body, some in various strange places as well. You don't want to know about those.
I really don't want to know.
And they go off and The hot and cold trade, you went to Materi in Cyprus and did the trials out there in proper temperatures. Or you can have basic equipment on here, navigation, cameras, clothing, well not clothing so much, but whatever they wanted to do to you, that's what would be on here. And then you'll be able to see all your different types of electrodes, your gas supplies coming through. And that sort of thing.
So in the video, he was using something to say when his vision was...
Yeah, there was a light bar would be attached. The light bulb would be attached from the back there and come through here and come down, and you'd have an armrest and joystick. So you were sitting there and you were going round, and what would happen is, it's like Stu would say, it's like a curtain coming in.
Yeah.
So if you weren't straining, it would come through, and it was shut, and you'd move out. But when you do all the equipment and you did your straining, you could control it coming backwards and forwards. And it had two little red lights in the middle, and that was the light bar, which was very good to use, made it more accurate.
Yeah. That looked impressive.
Yeah, that's still around somewhere.
Such a nice, simple idea.
It is, yeah.
I've never sit in there.
I'll try it in. So you've got your cameras there constant at all times, so you can see each other. So the doctors can see you quite happily and talk to you. It'll be the same if you're on the other side on that. But I was told, I believe, that they did try it before they had cameras and everything.
Yeah.
Before they had the TVs, sorry, not the cameras, but the TVs, with two people.
Yeah.
Because people's physiology is different, they mess each other's experiments up. So,
Yeah.
so that's why they only go to one,
Yeah.
and one depending on what they want to do.
Yes, I can imagine you're just getting some useful data off your
And
experiment.
somebody has to come down because
Yeah.
somebody's passed out or thrown up. Hence
Yes.
the little green bats.
Yes. We were having that discussion back.
Yeah.
Okay.
Like to just go down backwards. Again, be careful.